It's a 600-foot tall building with huge pieces of granite on the outside and huge ribbon windows that are logistically going to be complex to replace. One of the aspects was just the stone itself, the huge size pieces, and the fact that we were experiencing cracks in the edges of the stone.
There was a lot of spalls on the building, and we felt that there had to be some underlying reasons for that. The contractor came up with a method of building a steel frame which they attached to the stone and then hooked that to a chain fall which allowed them to pull the stone off the building, which exposed the construction behind the stone, which consisted of a steel shelf angle with a steel, what we call a lug, welded to it. The lugs were in very bad shape, they were rusted, they were putting pressure on the stone, and we believe that that's why there was so many spalls. Before we had made the final decisions on what repairs needed to be made, we felt that building a mock-up off-site would help us understand the existing conditions better than hanging 400 feet above the ground. So we had the contractor build a mock-up in a warehouse of a column cover as well as a fairly large section of the all granite walls. The mock-ups were built just like the building was built. So we used the same size angles, the same size lugs, same size anchors. We used the column cover to determine how to remove the pieces and how to insulate behind the column. That was one of the program requirements, was to get additional insulation in there. We also used it for fire stopping. The wall mock-up we were going to use to evaluate our methods of repairing the building. After all the investigation that we did, we felt that the number one problem was the rusted lugs. So we felt that they had to come off, except it was too expensive.
Cost effective. We had to come up with a cost effective method to do that. And that's where, working with our design assist contract, Berlin Construction, Turner Construction, Thornton Tomasetti, we came up with a method to use a CTP anchor to hold the stone into place while we could cut out the bad rusting lugs.
So we came up with a product called a CTP anchor, which is placed through the stone and into the backup material, again on site without removing the stone, and that anchors the stone in place and provides the lateral support we lost by removing the lug.
So the point of that is the state was looking for a solution that didn't have to remove the stone to repair it. And this is exactly what this solution did. It was cost effective because we could drill and put the anchors right back into the steel angles. Same time repair where the stone had cracked or to where we had to cut it out. And also gave us a method for repairing the spalled stones that came off, over 500 of them, to anchor them back in with that same CTP anchor. We're going to replace all of the glass in the building from the 7th floor to the 40th floor. The existing frame is a non-isolated frame, double insulated glass, but we lost a lot of the seals in the windows and they just weren't performing well. There was a lot of solar heat gain coming in through the outside, and that was affecting the temperature around the building since the controls did not facilitate movement around the sun of the building. So we came up with a glass with a solar heat gain of a very high factor, but it increased both the silvering on the back and it increased the darkness of the glass. So we tested that out by getting actual samples installed in 5 different windows with 5 different types. And we also brought and tested a new aluminum frame on the side of the building that we would try.
There was a lot of back and forth between our office, Thornton Tomasetti, and the glazing contractor, which was Pioneer Glazing Systems, on the profiles and sizes and performance of the new windows. Then they built a full-size window that would be then tested in a laboratory in York, Pennsylvania.
It was tested under the code wind loads that were required, plus our specification requirements for wind load as well as water testing to make sure Brian actually got inside and watched to make sure no water got inside while they were actually doing that test.
Between Pioneer and Thornton Tomasetti, they devised about 24 tests that would be required. Everything from static loading to dynamic loading with water, air, and structural. We also did a thermal test where we dropped the ambient temperature down to 0 and then brought it back up to 90 or so. Now that that's complete, we know exactly what product we're getting, what glass we're getting, and the contractor's in the process of producing shop drawings for the entire building.
We're also replacing all the sealants on the building, both at the stone and at the windows. This gives us an opportunity to reseal the entire outside. And we're down to the right sealants based on the joint widths. The only thing we have left to figure out is the right color.
Given the height of Rhodes Tower and the lack of observation points, the need for drone footage is really necessary. We use the drone footage for doing the COR. The video footage helped us in many ways, like figuring out what the stone joint pattern is.
There are some sloped roofs that you couldn't see at all from the ground or from adjacent buildings. It helped us with that. And we used it to zoom in on where we thought there might be defects.
The biggest challenge while reviewing the drone footage is mainly to keep track of what floors you are looking at. Since it is a 40-story building structure, we have to stop at every single second of the video, take a screenshot, and then zoom in to look for any potentially hazard stone pieces.